Hey everybody, this is Larry, this is me going with Q4 of the Bi-Weekly Contest 103, whoops. Make array empty. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one, assuming that you read through it, it's easy to understand, right? And actually there really is no craziness about it in terms of algorithms per se. And I say this very precisely because the tricky part is actually around the data structure. And if you actually watch the live portion of the video, and I'll explain what I did, is actually I actually did it kind of and this is probably why I did this a little bit slowly during the contest, is because I actually knew what I wanted to do, but I didn't. I was missing the data structure piece, so I was actually doing it in a I wouldn't say incorrect, but I was just like, oh. And then as soon as I noticed what I needed to do, I added in the data structure and it was fine. Maybe that didn't make any sense, so I'll go over it. Don't worry, I'll go over it slowly, but I just want to give an abstract look on how I attacked the problem with this problem, right? But a short story about this one, the beginning is just simulation. And what I mean by simulation, it just means to simulate the problem as they tell you, because this is basically like, this is like, there are no decisions, right? It's just like, hey, you have to do this, and then do this, and then do this, and do this, right? So you can simulate it by doing it. As of this time, I mean, I imagine a lot of people actually did the simulation, which will time out because n is 10 to the 5th, right? So, and the worst case is actually kind of easy, right? If you have the generate, I mean, you have the biggest, or you have the smallest number at the end, the second smallest number in the second to the end, and dot dot dot. That's going to be n squared, right? And 10 to the 5th square is going to be too slow. Technically, it's n squared over 2, maybe ish, but either way, it's still too slow, right? And then the other thing that you can think about, the way that I attacked this is that I did initially, and this is a little bit of spoiler already, is that, okay, so then now, what do I do, right? And I actually used my notebook a little bit just to kind of prove to myself. I think, to be honest, a little bit as well, if you see the people in the top and the fast time, I think this is a problem that people know about. I didn't remember this problem per se, but after I solved it, I was like, oh, I've done something similar. Maybe even possibly the same problem, just that I didn't remember it on Codeforce and other, maybe even Leetcode. I don't remember if this is, I don't know. Right? I'm too old to remember where I remember these things from. And I didn't even remember it, to be honest. But afterwards, I was like, oh yeah, right, I think I really did it. You know, I've done this problem before, or similarly. Okay, so all that said, so, you know, the other way to do it is just, the way, so what I call, so the first thing you want to do is optimize your simulation, because if you simulate it, like I said, it's going to be n squared. So then here, what I do is, first of all, re-index all the numbers. The numbers itself doesn't matter. All we care about is the relative rank, right? Meaning that, okay, the -1 is the smallest number, so let's put 0. 3 is the second, put it 1, and so forth, right? So now we convert this into a way that we care about, and we don't, and then, because then now we can ask ourselves, okay, where's the 0? Where's the 1? Where's the 2? Where's the 3? Dot, 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 right? And as part of that, maybe you can kind of figure it out, is that I said, where's the 0? Where's the 1? So then now, the next thing you can do is now just have a lookup thing that allows us to tell us where things are. So here, for example, the smallest number is at position 2, the second smallest number is in position 1, and then this is 0 actually, sorry. That's why I got a little confused. And then the third smallest number and so forth. So then now we have this array, right? Let me actually just, you know. So this is the rank, and this is the order to process, maybe, right? So basically now we want to to do the simulation, we're at position is equal to 0, right? And then now we're trying to go from, another way to say it is that we're trying from 0 to 2, and then back to 0, and then to 1, right? For this particular one. And here, this is what I did during the contest, and this is where I was like, oh wait, no, this isn't quite right, or not that it's not quite right, but that it can, if you don't do it carefully, it can still be n squared, because basically they're missing numbers, right? Let's construct a really weird one. Let's say 3 0, I don't know, 2 1 5 4 5, something like this, right? So then now we're saying that we're going to go from 0 to 3 to 0 to 2 to 1 to 4, 4 to 5, right? And you know, from 0 to 3 it takes 3 steps. Makes sense, right? 3 steps. You know, you just do the naive math, and then how many steps from 3 to 0? Well, there's 6 numbers, so it goes to 4, 5, and then 0 is the next one afterwards, right? So 2 steps, maybe, I don't know, maybe I'm just like off by 1 as well, but that's the idea. Right, and then of course here we want to remove 3. Remove 3, remove 0, right? And then now, how many steps from 0 to 2? Well, actually, that's still only 2 steps. I mean, I'm also maybe, you know, off by 1, like I said, because I'm not counting the removal, but that's fine. I'm just visualizing it. So remove 2, right? And then now, to go to, from 2 to 1, how many steps, right? Well, it's not, you know, you may think naively it'll go from 2, you know, it goes from 2 to 3 to 4 to 5 to 0 and then 1, right? That's how you would do it in a normal thing. But you have to keep in mind that we already removed the 3, we already removed the 0. So here, it actually is only 3 steps or 4 steps. I don't know. I don't remember how this, I just say it's 3 steps, right? For this part. And then now 1 to 4 is a similar idea, right? So then now 1 to 4 is 1, 2, 3, 4, but 2 is done, 3 is done. So then now this is only 2 steps, or maybe 1 step, I guess, and then remove a, right? And also remove 2, right? I forgot to say that, but, and so forth. So then now this is at the point where I realize, oh, if we were to simulate, what am I doing, right? Well, in this case, for example, in 1 to 4, another query that I'm asking is, how many numbers did we, say this is 1 to 4, did we remove from 1 to 4, right? And then similarly, from 2 to 1, this is the other case where you have to wrap around, right? Then you have, how many numbers did we remove from 2 to 1? But a subproblem that allows us to help solve this easier is, how many numbers did we remove from 2 to, in this case, to 5, because that's the last number, and then how many numbers did we remove from 0 to 1, or something like this, right? Because now, after 5, it's going to be 0, and then kind of that way. So so the point I want to point here is that this decomposes into these 2 queries instead, where 1 to 4 is just 1 query, right? Okay, and then of course, so here, just to go back a little bit on the complexity analysis, is that, you know, we have n numbers, we're going to have to remove n numbers, and that means that there's n iterations, right? So this is n iterations, n loops, right? So if we do this naively, right, if we do this in an O of n algorithm, then this will lead to O of n squared again. So we have to do this in faster than O of n. So how do we do it in faster than O of n? Well, we can do it in O of log n is 1. And that's basically the way that I did it. I also realized that, I just realized just now, there's also another way of doing it, maybe, but I don't know if I like it better, which is how many numbers did we remove from 1 to 2 minus how many numbers are there from 1 to 5, or 0 to 5, sorry. From 0 to 5 minus this thing, right? So you can also do it this way, but I don't know. It probably is equivalent for my head. It just makes more straightforward sense to do it this way. But yeah, so if you could do this in log n, then this is easy, or easy complexity wise, because now this leads to, obviously, maybe O of n log n total time, right? And here is the same idea, right? We do 2 O of n queries. This still is n log n. So then now it becomes now we reduce this problem of how many numbers did we remove from a range, right? And with that, all you need is a range query, range sum query. So there are a couple of ways you can do it. There's range sum query, which there are a couple of data structures for. The way that I use binary index tree. So there are a couple. There's a binary index tree. There's what do we call it? Segment tree is probably the other one. And there are other things similar. I'm blanking in my head right now. I'm recording this a little bit live during the contest. The contest is still going on. But so yeah. So those are the things that allows you to do these queries in log n, and that's really pretty much it. I am going to say that for interviews, I wouldn't. I don't know. It's very weird. Definitely, what I say only applies to not India, not China, because I've heard some crazy algos in those regions. Not to be like, it is what it is. I'm not no judgmental on it, no judgment on it, but it is what it is, and it's ridiculous if you ask me. But maybe a little judgment, I guess. But that's not an issue of the people doing these things. It's just it is what it is. But in any case, so that's why for the purpose of this video, I'm not going to go over binary index tree or segment tree. In what it is and stuff like this. Definitely do your own research, do your own learning and outgrow and stuff like this, because frankly it just will take too long, and yeah, it just takes too long, that's all. But let's say we have these things that we can kind of copy and paste in as a data structure. Then we can go over the rest of my code, which is actually what I did. I actually have this done before, though apparently there is a typo. So I have to kind of change my template. But this is how I did my binary index tree. And basically it has, the thing that you need to know about it is that it has two APIs. One is that it increase index I by X. And then here is get sum of 0 to I inclusive, I think, right? Anyway, so now given these two API calls, basically now we have to do all the things. Actually, I guess I don't really use rank. I wasn't sure if I needed it, but yeah. So maybe I will just delete this real quick. But yeah, but this is basically all my code, which is pretty small, right? So pretty straightforward. In theory. So this is just to look up, given a number, return the index from the original array, and then here is that given this doesn't have to be a dictionary. This is pretty much an array, but basically what is the number at position X, so that we can kind of do a lookup of it, right? The index, and you can kind of, just as a spoiler, this is how I used to look it up. And of course we increased the index by 1 so that basically at the end of this, if you look at the binary index tree, which is not what it looks like, but if you kind of think about it as the prefix, or just like at the storage, then at every index there's one element. And then if you kind of skip ahead slightly, when we remove an element, we set that index and then we subtract by 1. So that's basically the idea behind using the binary index tree. And let's get to it, right? So steps is the number of steps that we took, and current is basically the current index. And basically now for every iteration, we're trying to go from current to P, right? This is a P. Basically, we're going to the right. This is we do this thing, and this is basically this part, right? We're going to a smaller number to a larger number. We're going to the right. So then we just calculate how many numbers we have to remove inclusively. And the reason why this looks like this is just how the prefix sum looks like. It basically counts the number of numbers between the current number and P minus 1 inclusively. And that's the number of steps you have to take. And then now we delete P, and then we set the current number to P, right? Otherwise, this is to the left. So then now this, you can think about this as going all the way to the left. Oh, sorry, yeah, all the way going to the right to the last number, and then from the last number to the current position, and then again we move, and then we set update current, and yeah, and apparently I could actually have done this as well. Yeah, whatever, right? So it's slightly cleaner. But yeah, and then we add one more step for the actual removal, and that's pretty much it. Yeah, like I said, n iterations, log n time. Well, two of them, 3 of them here, log n time, and this is gonna be n log n in total. So yeah, that's all I have for this one. Let me know what you think. But basically, it's just simulation in a way, funky way. So yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye. Oh wait, yeah. Well, I'll still see you later and take care. But you can actually watch me solve it live during the contest now. Distinct numbers. First element at the end of the array. So repeated small 10 to the 5th, okay. I don't know how to do this. Wait. Basically, this is going to be 1, 2, 0. That's 2. Why is that 5? Oh, removal is an operation. Okay. Okay, that's fine. Let's say the number is not at the end, right? 1, 0, 2. Now this is going to take 1. This isn't hard, but in theory, just a lot of maths. In theory. I'm surprised no one got it yet, though. It doesn't seem, unless I'm thinking about it wrong. Are these distinct? Okay. So just normalize it. So rank of numbers. No, wait. Do the reverse. Okay, fine. Wait, do we? No, we get the. We need. Still surprised no one got it yet, though. But people are probably way close. first one. No, that's not right. This is wrong. What am I doing? The rank is wrong. And then so then the first, is that what I want? Okay. Oh, someone got it already. So okay. If this is greater equal to current, then steps we added to I minus current plus 1. Else, I have to do some maths. Oh, and this sets current is equal to positions of I. Maybe I have to do re-indexing, don't I? Do I? So I need like a binary index tree, don't I? Okay, fine. Where's my binary index tree code? Okay. I don't even know if I need this, to be honest, but okay. And then now we remove at position I, so that's how many things are used. So now we want to, so now instead of we want to get bit dot total sub position of I plus 1 maybe. Maybe plus 1, I don't know. Okay, I guess this is a little bit trickier, but otherwise we get bits. We go to the end. Okay, so we is it n or n? Oh, n minus 1 minus, and then no, this is from current, and then we go from plus 1. This is probably off by 1 or something, but in theory it should be okay. Maybe. What? 93. 926. What? Bit object has no attribute. Oh, whoops. Huh. My template seems to have bad code. Oh, just by 1. It might have been that I also do it the other way though, so maybe I need to do this by -1 and then I just go. I don't need to look up. I think I'm good. I mean, it's going to take a little bit to debug, but I think that idea is fine. .575, that's not quite right. Okay. Yeah. Okay, so this was. That's not right, right? So position sub I is wrong. Rank sub X is index. Okay, this is just silly. This is X. But no, but so we want, what we might do, this part is wrong. What we want is, okay, this is sorted by the smallest number. Oh, I see. Num sub I. Okay. Wow, so much copy and paste. Well, I didn't copy and paste, just typed it out, but still, so much of it. Position of no, that's not what I want. What I want is, oh geez, what do I want? I want the smallest number, and the smallest number is X. Okay. Alright, so position of 0, so that's right. It's going to be num, and then rank of that number. Now I need to look up. That's why I need to look up. So many layers that I got confused. Okay. 785. I mean, this is not right, but it's close, maybe. Okay. So 2, and then now this is at 2, and we don't go 0. Okay, so this part is right. This part, oh, 2 is 0, isn't it? That's why this is wrong, and this is just wrong in general, but okay, so it's at 2 and it's at 0 and it wants to go to 2. Okay, I have to debug these off by once, but I think ideally we're okay. Okay, so then now this takes 3, that's right. 2 to 0 takes 2, which is wrong. No, this part is 0, and then it just goes to maybe that part is not necessary. It's 0 to 1. It should be like, that's the part that I think maybe I didn't realize. Maybe. Okay, so 3 and then 4. It's not even I don't get it. It should still be okay. Oh, but the 2 part is right. Okay. I don't think that should matter though. If I do it correctly. But I have not been doing it correctly, so okay, so it doesn't if I do it correctly. Does this have a +1? I don't know that this has a +1. Okay, 4, 4, 2, which is really wrong. Okay, so this is 2. This is the position minus bits total of 0 because that's what it was getting to. It is the same space, but maybe here is fine, but that means that something else is wrong. This is fine. 2 to 0. So there's this part. Yeah, should be faster on this, to be honest, but it is what it is. Okay, 2 and 2, so this is 0, that's fine. And then P is 0. Oh, this should be P minus 1, that's why, maybe. And then here, P minus 1 to get to in front of it, maybe. I don't know. What if P is 0? In this case. Well, I guess this just returns 0, but that's fine, I guess. That's actually pretty good. But, okay. So, 0 and 2, it takes 2 steps. Nope. It's current minus 1 as well, maybe. That's why. Okay, 5, 5, 3. Let's double check just the numbers. Okay, 3, 4, 5, that's good. 0, 1, and then it goes to 4, goes to 3. I mean, this checks out. I'm going to YOLO, even though I'm not super confident about it. I don't know if I'm, maybe I'll just do like 3, 2, 1. Feels right. Please. Oh, cool. A little bit slow on that one, to be honest. It wasn't that bad. I just a lot of I mean, I like this poem. I just had a lot of off by ones. I think the off by ones is just a symptom of me not having a deep understanding of binary. Well, I mean, part of it binary index tree, part of it prefix sum, and really not being precise in what I want to do. Because it basically it was me having issues with inclusive exclusiveness, if that makes sense. And I wasn't sure if I should be inclusive or exclusive on the bounds. So that's basically why after I fixed all the negative ones, it's fine. But yeah, it's a little bit awkward for sure. Hopefully I get top whatever. People got that really fast. Wow. I mean, I'm not that surprised knowing the answer. I'm not that surprised. But maybe top 50 hopefully. I was very fast on the other ones apparently. Huh. Was I even like, I mean, there's no China here, so it's hard to say. I might have been even like top 10 on the first 3 or something, maybe. I don't know. yeah, I mean, I kind of knew what I wanted to do, but I just didn't do it really that fast. This is cool though. I mean, if I just have not. I mean, I'm just out of practice on this one. Um, yeah, I mean, yeah, there's really not much about it. I just am out of practice on this kind of thing. Because binary index tree is not really something that people use that often, to be honest. On interviews and stuff like this, it comes up nowadays. It comes up a bit on competitive programming, but I haven't been doing them. So, yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, everything in between. I'll see you later. Stay good, stay healthy, take good mental health. Goodbye and take care. Doo-doo.